Hello and welcome back to this channel. Dear students, today's topic is IIR filter design. We will be discussing solved examples related to this topic. There are two methods as far as IIR filters are concerned. Before that, IIR stands for infinite impulse response. So two methods are used for designing of IIR filters. First, impulse invariance method, and second, bilinear transformation method, abbreviated as BLT. First, we will solve the numerical related to impulse invariance method. You need to memorize only simple set of formulae. The poles of impulse invariance method are denoted by P to the base K. It can be P1, P2, P3 and so on. Using this method, they are transformed into the new value e raised to pkts into z raised to minus 1. One more equation you need to know. All analog filters are designed using Laplace transformation. That means you will be given the equation of h of s. So it should be in the form a1 upon s minus p1 plus a2 upon s minus p2 and so on, where p1 and p2 are poles of analog filter. From the given equation, you need to rearrange the equation of h of s in this format. Then using this transformation equation, we need to generate equation of h of z. We will solve the numerical, then the steps for this formula will be more clear to you. So first problem is calculate h of z using impulse invariance method at 5 Hz sampling frequency. So sampling frequency is given in the question. It is denoted by f of s, which is 5 Hz. This is equation of h of s, which is again given in the question. Already the roots are given, so we don't have to calculate the roots. What we need to do, we need to write the equation in this standard format. How to do it? So in case similar to the partial fraction expansion, we can express the given equation in PFE, that is partial fraction expansion form, as a1 upon first bracket, that is s plus 1, plus a2 upon second bracket, that is s plus 2. Now always remember, these given values are s plus 1 and s plus 2. So while deciding the positions of poles, P1, that is first pole, will be at minus 1. This is the common mistake. One should avoid it in the exam. Given value is s plus 1, change the sign of this value. So P1 is first pole, that is minus 1. Similarly, P2, that is second pole related to second term, given value is s plus 2. So change the sign, it is minus 2. Now, our task is first to calculate values of A1 and A2 using partial fraction expansion. How to do it? If I want to calculate A1, I am referring this given equation, say equation number 1. To calculate A1, denominator of A1 is s plus 1. Skip this denominator, write down the remaining equation 2 upon s plus 2 and do this calculation at s is equals to P1. That means s is equals to minus 1. So wherever s is there, I am putting value minus 1. So it becomes 2 upon minus 1 plus 2. That is equals to 2. This is the value of A1. Same way, to calculate A2, what I need to do, look at this equation. Denominator of A2 is s plus 2. So in given equation, in equation 1, skip the term s plus 2, write down the remaining equation as it is 2 upon s plus 1. Do this calculation. This vertical line indicates do the calculation at s is equals to P2. That means P2 is minus 2. So put s is equals to P2. Wherever s is there, I need to put s is equals to minus 2. So this equation can be written as 2 upon minus 2 plus 1, that is equals to minus 2. So I have got the values of A1 and A2. A1 is 2, A2 is minus 2. So I will write these values over here. A1 is 2, A2 is minus 2. Next part is, this is the formula which is used to transform the poles of analog filter, given filter, into the digital filter. So how to do this calculation? First pole is at minus 1. First I will write the formula. Pk is transformed into e raised to pkts into z raised to minus 1. So first pole is at minus 1. So I will write it like this, minus 1. I am choosing first value. It is transformed into e raised to minus 1 into ts. What about ts? See, Fs is given. Fs is sampling frequency. It is 5 Hertz. Ts is reciprocal of sampling frequency. So from this I can write Ts as 1 by Fs, which is equals to 1 by 5, which is equals to 0.2. So value of Ts is 0.2. So I will put the value, this e raised to minus 1 into Ts, value of Ts is 0.2 into z raised to minus 1. Using calculator you need to obtain this answer, that is e raised to minus 1 into 0.2, that is e raised to minus 0.2. So this answer will be 0.818. Same way, using the same formula, I have to transform the second pole into the digital domain. So minus 2 can be transformed like this, e raised to, look at this equation, in case of pk I am putting p2, that is minus 2 into ts, ts is 0.2 into z raised to minus 1. So it is e raised to minus 2 into 0.2, e raised to minus 0.4. Again I will be doing calculation on calculator, so this value will be 0.67. These new values, whatever we calculated by doing this transformation formula, are denoted by P1 dash, second value is denoted by P2 dash. Now the last step. In the last step, what we need to do, we need to make use of the equation of h of z. I mean the standard format of h of z which I have written. How to make use of this? Values of a1, a2 we have already calculated. The values remain same for h of s as well as h of z. Just put the value of p1 dash and p2 dash. So in this case, I will write equation of h of z using this formula. I am writing a1 is 2 upon s minus p1 dash. Value of p1 dash is, this is h of z is a1 upon 1 minus p1 dash. Value of p1 dash is 0.818 z raised to minus 1 plus second term, value of a2 is minus 2, so I will write minus and 2 over here. Actually it is a1 upon this thing plus sign, but value of a2 is minus, so I am writing minus 2 upon same formula. So I need to write 1 minus, I am using this equation, p2 dash is 0.67, so it is 1 minus 0.67 z raised to minus 1. This is the final answer. If you want to transform it into standard format, multiply and divide by z, but up to this stage the solution is okay. So this is the transfer function of digital filter. Let us solve few more numericals to get an idea of these methods. The next problem is convert analog filter into digital filter using impulse invariance method if this is the equation of h of s, 10 upon s square plus 7s plus 10. Now in the last problem the roots were directly given. So first step is we have to calculate the roots in this case. So if I will do the calculation of roots of this equation s square plus 7s plus 10 on the calculator, then I will get the equation like this. So h of s is equals to 10 upon first bracket will be s plus 5 and second bracket will be s plus 2. So on the calculator I am getting the roots minus 5 and minus 2. Similar to the last sum, what I said, if you are getting s plus 5, then write first pole, that is p1 is equals to minus 5 by changing the sign. If you would have got s minus 5, then you would have written p1 is equals to plus 5 and so on. Then p2 second pole, same logic, this is s plus 2, so p2 second pole will be at minus 2. Now remaining steps are pretty similar to the previous problem. So to write it into the standard format, I will express it in partial fraction expansion as a1 upon first bracket s plus 5 plus a2 upon second bracket, that is s plus 2. Now I need to calculate the value of a1 and a2. To calculate a1, consider this given equation, skip the term s plus 5, write the remaining equation 10 upon s plus 2. Do this calculation at s is equals to p1, that is s is equals to minus 5. So wherever s is there, I am supposed to put minus 5. So it becomes 10 upon minus 5 plus 2 So it is minus 10 by 3, which is minus 3.33. Same way to calculate A2. I will skip this term, second term, that is s plus 2. Remaining equation is 10 upon s plus 5. Do this calculation at s is equals to minus 2. That is s is equals to P2. So wherever s is there, I need to put minus 2. So it becomes 10 upon minus 2 plus 5, which is equals to 10 upon 3, which is equals to 3.33. These are the values of A1 and A2. Now simply we have to make use of the same formula to make the transformation into the digital domain. So I will write the formula over here. Formula is Pk is transformed into e raised to Pk Ts into z raised to minus 1. Now very important part. In the last problem, Fs, that is sampling frequency, was given. So we could calculate the Ts, that is sampling time. In this case, nothing is mentioned about sampling frequency as well as the sampling time Ts. So in such cases, always and always consider Ts is equals to 1. If Ts and Fs are not given, by default consider Ts is equals to 1. So first pole, that is minus 5, I will transform it like this. Minus 5 is transformed into e raised to minus 5 into Ts. Ts is 1, so I'm keeping e raised to minus 5 as it is into z raised to minus 1. If you calculate the value of e raised to minus 5 on the calculator, it is 6.74 into 10 raised to minus 3 into z raised to minus 1, this term as it is. Same way, I need to transform second pole, that is minus 2, using the same technique. It is e raised to minus 2 into z raised to minus 1. Value of e raised to minus 2 is 0.135 into z raised to minus 1. Remaining steps are same like the previous case. So what I need to do, I need to put the values of A1, A2 and new poles P1 dash and P2 dash in this equation. So this pole, this new values, I will denote it by P1 dash and second pole by P2 dash. So equation of h of z can be written as h of z is equals to, I am using this formula, A1 and A2 remains same like the previous calculation. It is 3.33. We have already calculated these values upon 1 minus P1 dash. Value of P1 dash is 6.74 into 10 raised to minus 3 into z raised to minus 1. This is first term, A1 upon this first term. Second term, value of A2 is 3.33 divided by, same way, 1 minus P2 dash, 1 minus value of P2 dash is new pole, 1 minus 0.135 into z raised to minus 1. So this is the final equation of digital filter. These are the two variations as far as the impulse invariance method is concerned. Now let us solve a numerical related to BLT, that is bilinear transformation. The next problem is the transfer function of analog filter is h of s. This is the given equation. Obtain transfer function of digital filter using BLT, that is bilinear transformation, which is resonant at omega. Omega is the frequency of digital filter. Omega is pi by 2. Now, for BLT, bilinear transformation, we just have to remember this simple formula. If you replace s by 2 by th, z minus 1 upon z plus 1, h of s will be converted into h of z. But this is something different numerical. See, in such type of numericals, in BLT, you need to calculate ts. In the impulse invariance method, what I said, if ts or fs is not given, you can consider the standard value, that is ts is equals to 1. But in this case, omega is given. This equation is given in different format. So in such cases, we need to calculate value of ts. How to do it? We need to make use of one more formula for BLT, that is ohm is equals to 2 by ts tan omega by 2. This is the relationship between, this is also known as, it is read as omega, but for the simplicity, I will call this thing as ohm. So ohm is frequency of analog signal. which is 2 by Ts tan omega by 2. Ohm is the frequency of analog signal, omega is the frequency of digital signal, Ts is the sampling time that I need to calculate. From this equation, I can simply write Ts is equals to, what I am doing, I am interchanging Ts and omega, so Ts is transferred to the LHS, so it can be 2 by ohm into tan omega by 2. Now, what I am supposed to do, I need to know the value of ohm because omega is known, then and then only I will get value of Ts. How to get the value of ohm? This is the given equation. In such type of equations, look at the numerator, it is s plus 0.1. Same thing is there in the denominator, which is at the first term and it is bracket square. In such cases, the constant term at the end of denominator is ohm square. So in such kind of numericals, if numerator term, then denominator term, square of the numerator term plus some constant term, then last term, which is a constant, is denoted by ohm square, which is 16. Therefore, I will take ohm is equals to 4. So now it's pretty simple. Just put the values 2 by 4 tan omega, value of omega is given pi by 2. So tan of pi by 2 divided by 2. If you solve this on the calculator, and don't forget to keep the calculator in radian mode because you are doing the calculation with value pi, so keep calc in radian mode. If you solve this, you will get the answer of Ts is equals to 0.5, that is the sampling time. Now remaining part is simple. Wherever s is there in the given equation, put the value 2 by Ts, z minus 1 upon z plus 1. Now here 2 by Ts is 0.5, so it becomes 2 by 0.5. So this value you need to put in case of in place of s in the given equation of h of s. So directly you can write the equation of h of z as, what I said, in place of h of s you have to put this value. So the equation can be written as 2 by Ts, that is 2 upon 0.5, which is 4. So it becomes 4, I am putting value of 2 by Ts, 4 into z minus 1 upon z plus 1. In place of this as I am putting the value plus 0.1 divided by same thing, 4 z minus 1 upon z plus 1. In place of this, yes, I am putting value plus 0.1, the bracket square plus 16. If you want, you can further simplify it, but not necessary. Up to this step, the solution is okay. So this is the case as far as BLT is concerned. So these are the 3 different numericals which covers all the variations as far as this IIR filter designing is concerned. So that's it for today's session. Thanks for watching this video. Thank you very much.